Hi, my name is Karen, and this is my study on the effects of ultraviolet radiation and temperature on biodegradation. Polyethylene terephthalate, or PET, is the most widely used plastic in the world. However, it takes up to 1,000 years to decompose and has many negative effects on the environment. One solution is bioremediation, which is the use of living organisms to decontaminate ecosystems by breaking down its pollutants. By using biotic components in situ, this avoids the need for harsh chemicals and costly extractions. One example of microbial bioremediation uses Bacillus subtilis, which is a bacterium that can naturally degrade PET. The bacterium uses PET as its main energy source, and by using naturally occurring bacterial strains as opposed to genetically modified strains, researchers can track the metabolic pathways of the biodegradation process. Many current studies on biodegradation focus on genetic engineering. However, the objective of this study was to determine the UVC radiation and temperature thresholds at which PET is most susceptible to biodegradation, while Bacillus subtilis can remain viable to continue the biodegradation process. It was hypothesized that this would occur after UVC exposure at a temperature of 50 degrees Celsius. In order to test this, I exposed PET strips and B subtilis samples to UVC radiation and various temperatures. Before I jump into the procedure, I would like to highlight Table 1 on the bottom right. The 60 samples were split into 6 groups of 10, and group letters denote UVC exposure while group numbers denote incubation temperatures. After establishing the groups, vials were inoculated with B subtilis in lurea broth, while Group B PET strips were exposed to UVC radiation. Then, PET strips were placed in each sample vial and incubated at the group temperature. PET strips were extracted and masked, and turbidity of lurea broth was measured. Finally, 3 random samples from each group were plated, and Group B samples were exposed to UVC radiation. PET degradation was measured with mass, and B subtilis viability was measured with turbidity and bacterial area coverage. From this, I organized the results into tables. In Table 2, a Teague test calculated no significance between mean PET mass before and after UVC exposure. Table 3 shows the mean turbidity before and after incubation, and Table 4 shows mean % change in bacterial coverage before and after UVC exposure. Figures 5 and 6 show that at higher temperatures, mean PET mass increased significantly. Figure 7 shows that turbidity increased significantly during incubation, and Figure 8 shows that this increase was significantly greater at 30 degrees Celsius as compared to 40 or 50 degrees Celsius. So, what does this all mean? Starting with PET degradation, as you can see in Table 2, UVC radiation did not significantly affect PET mass. It likely affected the PET on a molecular level, altering the chemical bonds but having no effect on mass. As for incubation, Figure 5 shows that PET mass increased significantly after incubation at 40 and 50 degrees Celsius. I deduced that a biofilm formed on the surface of PET, which increased mass. Overall, no PET degradation was detected in this study. However, scanning electron microscopy, like shown in Figure 9, could be used to analyze changes on the surface of the PET. Moving on to bacterial viability, Figure 7 shows that turbidity increased significantly at all 3 incubation temperatures, showing that the viability of B subtilis was successfully maintained. Additionally, bacterial area coverage did not significantly change after UVC exposure, as seen in Figure 10. This indicates that B subtilis successfully survived exposure to UVC radiation. Overall, the hypothesis was corroborated in that B subtilis remained viable throughout all the extreme conditions presented in this study. However, no PET biodegradation was detected. Possible underlying factors that could have impacted the results of this study include the formation of a biofilm and molecular changes. The study was conducted in controlled conditions, which do not accurately reflect the environment, where plastics could be exposed to other factors such as chemical changes and broad-spectrum UV, which could be explored in future studies. Thank you for listening to my presentation. Scan the QR code for my research report and feel free to email me with any questions. I hope you have a wonderful day.